Hello, good evening, students. Welcome to Origin's computer classes. In this lesson, I will be discussing about the different data types and its size and how to use them. What are their format specifiers, right? Now, if I talk about my previous video, I have discussed about only integer data type and the data types that we have in general. If you remember, in my previous video, I was using here a modulus d each time I was printing the value of a variable. So what is this modulus d actually? So for whatever method we use, the built-in methods, which is where we send some data or accept any data there, or anything associated with data in C programming language, we need to mention the type of data that we are using. In that case, for methods, we use the format specifiers, and for declaring any variable, we directly use the name of the data type that we are using. So let us start with a new file today. So it is, let us name it as data types.c. Okay. So the basic structure of the C programming language, this basic syntax include str.h int main, it return 0. Fine. So here let us first talk about the types of data types that we have in C programming language. So let me open my paint window. Here we have for the basic data types that we have in C are character. Okay. Then we have int, that is the integer numbers that we store, float, long, double. Okay. And nothing else. And both the true false are represented by zeros and ones. So we don't have boolean data type in C, unlike Python. So here we have only these data types: character, int, float, and long and double. Okay. So what is the character data type? So the character data type you represents if the data is a character from your standard input device. Let's for example, let us declare a variable of character data type, and character ch is equal to, we type some character, for example say capital A. Now remember, a character variable can only store one value at a time, right? It can't store more than one character. Okay. For the character data type, for strings we just convert it to an array of characters somehow, that we will be discussing in our upcoming videos. But for now, be very specific that character means only a single character, and it does not include more than one characters. Fine. Okay. So let us see. And for any method, be it accepting characters or printing characters, the format specifier used for character data is mod c. Okay. And then we print the variable, the value of the variable, that is ch. Fine. So if I save it and run it, we should get a. Yes, we are getting a. Okay. Similarly, whatever you type here, that will get printed. Say for example b. Then if we save and run, in that case we have b in our output. Okay. So the format specifier for character data type is c, and in a 32-bit compiler it occupies 1 byte, 1 byte of space. Okay. So the space occupied by the by your device depends on the type of compiler you are using. So if you are using 32-bit compiler, it is going to occupy some amount of space, and for 64-bit it will be occupying another some amount of space. Okay, and now this same character data type, we have other ways to represent. Now, as we know, our machines understand only zeros and ones, the binary language. Okay, so how were these characters understood by our machines? Okay, so from, we can say, from A to Z, in as we follow ASCII characters, ASCII values for each characters. Okay, and the ASCII values are being converted into its binary equivalent, which can be understood by the machine. Okay, so from A to Z, the values we have from 65 to 90. Okay, from small a to small z, we have values from 97 to 122. Now, what, in total we have 128 ASCII values, ASCII characters. I mean to say 128 total characters in ASCII. So from 65 to 90 we have capital A to Z, and from small a to small z we have 97 to 122. And then what about the rest? The rest actually contains the values of 0 to 9, the numbers. The 0 to 9 we have, because 0 to 9, the numbers can also be represented as characters sometimes, right? And from 0 to 9 we have values from 48 to 48 to 56. Okay, 48 to 50, yeah, 57 actually, sorry, my bad. So, and the rest ASCII characters, rest ASCII values have special characters in them. The dollar, the asterisks, and the hashtags are also stored using the ASCII values. We can have a look at our ASCII table from the Google. So it is not possible for anyone to remember ASCII values for each and every character. Okay, so from the basic that we remember is, that is from capital A to capital Z ranges from 65 to 90, and the small a to small z ranges from 97 to 122, and the others everyone does a Google search. So ASCII table, and if we look at it, we can get the ASCII values from of all the, so here we will be only looking at the decimal equivalent for each characters. So, and for 65 we will be having, let us look at another table. See, for capital A to for capital A we are having, it is, for capital A we are having 65 from capital, these decimal values are to be considered, and 65, 66. So for other special characters we are having these values. So it has a variety ranging from 0, okay, 0 is actually null, up to 0 to 127. Total 128 characters we have in our ASCII. Okay, so you can go visit by Google. Okay, and then you can also do a research as per your requirement. You can access. So how can we actually access a specific character using its ASCII value? So let us check. Say if I don't know, I mean, if I want to use say dollar, or like say capital A, but actually I don't want any other programmer to understand that I am actually trying to print A, B, C or other characters. It actually depends on the requirement of the problem. As per the requirement of the problem, how you are going to print the character. Let us say we have taken a variable of integer data type and giving a value, say 65. Okay. And in the printf method, we are having modulus C, the format specifier for character. And if I print it now, as per that, as in ch we are having 65, and we are giving a format specifier of character. So this 65 will be converted into its equivalent character, and we should get A in our result. Fine. So let us check. Yeah, we are getting A. Let us check with another value, say 67. We should get C, because 67 is equivalent of C only. Let us check in our output. So that is your C. Fine. So this is another way of printing the characters or accessing the characters, better to say. Because in other depends on the problem statement. There may be given a program for encryption. It is a very famous program to play with characters, where you need to forward your character by 2 or 3, that something like that. So using character data type, actually we can't do any mathematical operations. In that case, we can use its equivalent ASCII value. Moving to our next data type, that is our integer data type, which has a format specifier. As you already know from my previous video, it has a format specifier of 2 bytes. I mean, it has a format specifier of modulus D and occupies a space of 2 bytes in 32-bit compiler, and in 64-bit it occupies 4 bytes. Okay. A character occupies 1 byte in both the cases, because for whatever character you write, it will be converted into same number of bytes and same number of bits, rather to say. So A will be represented as 1 byte only in both the compilers, but integer and float changes depending on the compiler. Okay, in C programming language. Integer, I hope I don't need to discuss much, because I actually have already discussed about this in my previous lecture, and so I am not proceeding about through integer data type in this video. Directly moving up to my next data type, that is float. For float, we have a format specifier modulus F, and this also occupies 2 bytes and 4 bytes in case of 64-bit compiler. Okay, and long can be represented as long. I mean, it is actually an upgraded version of integer data type, because integer can store up to a specific range. If I talk about 32-bit compiler, in that case, if I talk about 32-bit compiler, 2 bytes, that is equivalent to 16 bits, because 1 byte stores 8 bits, and 2 byte, it is equivalent to actually 16 bits. 16 bits. 16 bits. Okay, I'm just writing it below. 16 bits. So integer will range from a value 2 to the power minus 2 to the power that is the number of bits for integer minus 1. Integer stores 16 bits, so number of bits minus 1 to 2 to minus 2 to the power number of bits minus 1, that is 2 to the power 15. 2 plus 2 to the power 15 minus 1. Okay, and long data type can store actually a better number of bytes. Okay, okay, so these are the size that is occupied by the various data types in C programming language. And for double it is 4 bytes again, and 8 bytes in 62-bit a 64-bit compiler. Okay, so these are the various sizes of the data types that we will be having in C programming language with these format specifiers. Okay, you can check the size of each data type by using a function called size of. So if I say print, let us check the size of the data type, say size of. If I say character, in that case I'm working on a 64-bit compiler, therefore character remains same in both the cases, so I should get 1 byte. Okay, this is 1 byte. And if I talk about integer, then I must get, say this is then 4 bytes I should get. And yeah, it's 4 byte as I mentioned, 4 byte for integer. For float also I should get 4 bytes. So for float I am getting a size as 4 bytes. Now actually I would like to give you an assignment in this case. I want you all to check, if you are working with the VS Code environment, to check the size of this long data type and double data type if you are using a 64-bit compiler, and what output you are getting. Please mention in the comment section. Okay, actually these two data types have have a bit interesting facts that I will be discussing. First I want to check the comment section after posting this video. These these are the long and double data type has some interesting fact. Upon these various our operating system has worked. So ideally we should get 8 bytes in 64-bit compiler. Okay, I want you guys to test these two data types if you are working with VS Code, and let me know what you are getting in the comment section. Okay, fine. So let us proceed. And if I talk about double, just like long was a better data type for integer, because integer has this range, whereas comparatively long will be having a bit bigger range as it is occupying 4 bytes in 32-bit compiler. So 2 to the power 4 byte means it is 32 bits, right? So 32 bits means it is 2 to the power 31 minus 2 and plus 2 to the power 32 minus 1, right? And in the same fashion the range goes for other data types also. Okay, so let us check for the other data types. If I am printing, say this is now containing some other values. If I directly print the value of ch, I am also changing the variable name, say variable. Okay, int variable into var is equal to 6. So for integer data type, I should get 6. Okay. Now what happens if I write here 6.6? Now this is integer data type, and if I am writing something after point, it will be ignored, just nothing will happen. So I will be only getting 6. Okay, let us test it. So yes, again we are getting 6. If I change it to 7, we should get 7. But if I change this to float, in that case I will be getting, oh sorry, I have not changed the format specifier, that is why I am getting such output. So modulus f for float, and I should get as value as it is. Yeah, so 7.6 and the zeros that will occur. This is actually dependent on the size of the compiler. Okay. Now if I try say int, now int cannot store point actually. So if I just write 7 and if I give the format specifier as modulus f, then I am getting 0.000. Okay. Why we are getting this 0.000 instead of 7? Because we are actually giving the value integer, and the where is of a data type integer data type, but we are mentioning that the format printf, to printf we are giving a format specifier modulus f. So modulus f doesn't match with an integer data type, and so of course here we need to mention float. But if I want to convert any integer value to a float value, in that case what should we do? In that case, because depending, this is known as typecasting. So if I want to get 7.000 from the var value, the value of var, where var is actually an integer data type, in that case, if we write f var is equal to 7f, let us see what we get in the output. Just a second. In different programs, we may require that we need to convert this integer data type into a floating data type. And if we see the size of integer and float, both are same. So it shouldn't be a problem to typecast the integer. That means convert the 7 to its equivalent floating data type. For that, we can actually typecast it using a variable. Say we need to convert it into float. In that case, float f is equal to float, and then this where. Okay. And now if we print f, so float f is equal to float, that this is your typecasting of integer data type, and then we can print it simply. So we are again getting the 7.00 equivalent of float. And now here your assignment is to find the other way. Here actually we have another way of converting this integer data, right, into its equivalent floating value. Okay, so I want you guys to write that other method in my comment section. These I will be discussing in the next video, upcoming video. Okay, and similarly we have double. For double we use modulus LF, and modulus LF is nothing, just a bigger version of float. Just like for integer, the bigger version of integer is long. We have, say, float f is equal to, I am writing 8.96, and I am writing modulus LF is equal to, actually by default whatever we are writing in this float f, that can be considered as double. See, it is by default considering it as double. This value is actually considered as double because float and double, they are actually like mutual to each other. Just double actually stores a large value after decimal points, large number of values after decimal points it can fit. Okay, so by default whatever we are writing in this float, it is actually double, it is not actually float. In order to convert it into float, we can use an f symbol here. Okay, this I can actually prove by giving you an example. Say this is your modulus f, and if I consider the output is same in both the cases, right? But uh, just for an example, as you know, we can use if else statement. So I'm just showing you for an example, or better to say, I'm not. Uh, Instead of using if else, I'm just showing you something that is very interesting, and I want you to predict the output by pausing the video for some seconds. So I'm writing float f is equal to 8.96, and actually I want to check whether this comparison is true or false. So f double equal to, now this double equal to is used for comparison, the same thing that we have used in case of Python, same approach. So if I write 8 point f double equal to 8.96, what do you think? Because okay, just for your convenience I am saying that in C programming language false is represented by 0 and true is represented by 1. So if I write f equal to 8.96, what do you think the value should be? Should it return false or should it return true? Just pause the video for some seconds and try it on your own. Okay, so have you tried? Okay, let us check. F equal to 8.96, right? If I write so, what should be the value? Let us check. Okay, so it is 0. Why are we getting this 0? But f has a value of 8.96. Still we are getting false when I am comparing f with 8.96. The reason behind that is, by default whatever we store in a float variable, by mentioning float, okay, because double actually there is nothing called double actually in C. If I write double here, that has no meaning in C. Float, if I write something in float, by default it means it is actually double. It by default it will store it as double. Okay, now if I want to make it float data type, In that case, I need to mention an f here. Okay, so this f states that this actually being converted into float. This, why this result is giving false, because f, the value of f, as soon as I am assigning 8.96, it means it is 8.960000. Okay, and 8.960000, that is a double data type, and two different data types if I compare, in that case obviously the result will be false, right? If I compare integer with float, of course that will be false, right? So here I am comparing double with, okay, double with float actually, and that becomes false. Sorry, to be precise, double with double only, but it is 8.96 some zero, and then I'm comparing it with 8.96, that is float. Okay, in order to make it equivalent, this is double, okay, or this, if I consider this float f equal to, if I even consider this value as float, then this value I need to make as a float, right? And so 8.96 f, this f states that I am converting it into float. Okay, and now I should get my output as 1. Let us check. Yes, so actually I'm comparing now a float with float, therefore this becomes true. Only the exceptional cases are if you use 0.5, 0.5, right? In that case, you are supposed to get 1 even if you don't mention an if. Okay, so that was all about our data types in C. See you in the next video. Till then, bye. Take care. Thank you, guys.